In 1859, the Sun unleashed a fiery inferno, an event that would be remembered for centuries. A colossal solar flare known as the Carrington Event erupted from the Sun's surface with unprecedented force. It hurled a torrent of charged particles toward Earth, traveling at mind-boggling speeds. The impact was immediate and spectacular, lighting up the skies with mesmerizing auroras. Telegraph systems, the cutting edge of communication at the time, went haywire, unable to cope with the surge. Sparks flew from equipment, igniting fires and causing widespread chaos. Imagine that happening today in our interconnected world. Our world runs on electricity, from the lights in our homes to the devices in our pockets. A Carrington-level event today would be catastrophic. Satellites would be fried, power grids would collapse, plunging cities into darkness. Communication networks would go dark, severing our connection to the world. The internet, our lifeline to information and each other, would vanish, leaving us isolated. We are more technologically advanced than ever before, relying on complex systems for our daily lives, but this progress has also made us more vulnerable to the Sun's wrath. The Sun is a tempestuous beast, capable of unleashing its fury at any moment without warning, and as we venture deeper into the cosmos, our dependence on technology grows, making us even more susceptible. The question isn't if another Carrington event will occur, but when. Scientists are constantly monitoring the Sun's activity, and this time we might not be so lucky. Preparedness is key to mitigating the potential devastation. Deep beneath our feet, hidden from sight, lies a blazing sphere of molten iron, a seething cauldron that never cools. The Earth's core, a churning mass larger than Mars, burns with a fury hotter than the surface of the Sun, reaching up to a staggering 9,932 degrees Fahrenheit. This immense heat isn't just a fascinating fact. It's the powerhouse behind our planet's magnetic field, a protective shield against cosmic threats. Picture the Earth as a giant onion with layers upon layers, each boasting its own unique properties and composition. The crust, our home, is surprisingly thin, just about 18 miles thick on land and even thinner beneath the oceans. Think of it like the skin of an apple compared to the rest of the fruit, a delicate shell over a vast, mysterious interior. Beneath this fragile crust lies the mantle, a thick layer of hot, viscous rock that flows slowly like asphalt under a heavy weight. And at the very heart of our planet lies the core, a realm of unimaginable pressure and searing temperatures. The outer core, a swirling ocean of liquid iron, generates electric currents as it moves. These currents create a magnetic field that stretches far into space, enveloping our planet in a protective embrace. This magnetic field, our planet's invisible guardian, shields us from the relentless bombardment of cosmic radiation, deflecting harmful particles. Without it, life as we know it would vanish, leaving Earth a barren, lifeless rock adrift in the vastness of space. Picture a colossal bar magnet nestled within the Earth, aligned almost perfectly with our planet's axis of rotation. This is a simplified way to visualize Earth's magnetic field, an invisible force field that surrounds and protects us. This magnetic field acts like a shield, deflecting the majority of the Sun's harmful radiation. Without it, the solar wind, a stream of charged particles from the Sun, would strip away our atmosphere. Think of it as a cosmic umbrella shielding us from the Sun's relentless downpour. But this shield isn't just a static barrier, it's a dynamic force field constantly interacting with the solar wind. This interaction creates the mesmerizing auroras, those shimmering curtains of light that dance in the polar skies. These celestial ballets are a stunning reminder of the invisible forces that safeguard us. But what if this protective shield were to weaken? Mars, our enigmatic red neighbor, offers a haunting preview of what could be Earth's future. Imagine Mars, once a warmer, wetter world, possibly teeming with life. Today it's a desolate wasteland, its surface relentlessly bombarded by radiation. What went wrong? Mars lost its magnetic field billions of years ago. Without this protective shield, the solar wind mercilessly stripped away its atmosphere, oceans vanished. The surface, once potentially habitable, transformed into the barren landscape we see today. Could Earth face the same grim fate? If our planet's core were to cool down, Our magnetic field would weaken and eventually vanish. The consequences would be catastrophic. We would be exposed to the full force of cosmic radiation. Our atmosphere would slowly be stripped away, leaving us vulnerable. Earth could become another Mars, a stark reminder of the vital importance of our planet's fiery heart. Imagine a world where the Earth's core begins to cool. It wouldn't be an explosive event, but a slow, almost invisible transformation. This gradual cooling would unfold over millions of years, subtly reshaping our planet's very essence. Yet, even in its infancy, the signs would be unmistakable. Subtle shifts would start to ripple through our world. At first, these signs might seem trivial, easy to dismiss. Compasses, our trusty navigational tools, would begin to falter, their needles dancing erratically, leading to confusion and disorientation. Birds, masters of magnetic navigation, would lose their way, their flight paths turning chaotic, a testament to the shifting magnetic field. Whales and other marine creatures, guided by the same magnetic cues, would find themselves stranded on shores, a heartbreaking consequence of this change. Our surroundings would feel subtly altered, as if the world itself had shifted. Then the more dramatic effects would emerge, making the transformation undeniable. Auroras, typically seen near the poles, would start to grace lower latitudes, a vivid sign of the magnetic field's upheaval. These mesmerizing light shows, while breathtaking, would herald a deeper, more ominous shift within our planet. As the magnetic field weakens, more solar radiation would breach our atmosphere, presenting new challenges for life on Earth. As our magnetic shield weakens, the consequences would escalate dramatically. Satellites, our silent sentinels in space, would be the first to fall. Bombarded by cosmic radiation, they would malfunction and go dark. Our dependence on satellites for communication, navigation, and surveillance would be shattered. Power grids, already vulnerable to geomagnetic storms, would face catastrophic failures. Picture a world plunged into darkness. Hospitals would be crippled. Communication networks would collapse. Food would spoil in powerless refrigerators. Our modern existence would come to a standstill. Increased radiation would pose a dire threat to human health. Cancer rates would skyrocket. The air we breathe would turn toxic. Our planet, once a cradle of life, would become a hostile wasteland. Confronted with such a dire future, humanity would be driven to innovate and adapt. Visionary scientists are already delving into the creation of artificial magnetic shields, colossal force fields designed to shield Earth from the harshness of space weather. One groundbreaking idea involves encircling the equator with a network of superconducting cables, generating an immensely powerful magnetic field. Another bold proposal suggests deploying a gigantic electromagnet in orbit, serving as a formidable shield against incoming radiation. These are audacious and technologically demanding solutions, necessitating global collaboration and immense resources. Fascinatingly, the Earth's magnetic field is already weakening in a specific region known as the South Atlantic Anomaly. This zone of diminished magnetic intensity over South America and the southern Atlantic Ocean has scientists intrigued. Could this be a sign of what's to come, or merely a temporary fluctuation? The South Atlantic Anomaly is a vivid reminder that our planet's magnetic field is a living, breathing entity. It's a dynamic force, constantly shifting and evolving. While the anomaly's origins remain shrouded in mystery, it underscores the critical need to understand our planet's deep interior. The fate of Earth, our only home, hangs in the balance. The core, our planet's fiery heart, holds the secrets to our survival. As we journey further into the cosmos, seeking answers to the universe's grandest mysteries, we must also turn our gaze inward to the enigmatic forces that shape our planet's destiny. The future of humanity may very well depend on it. What secrets lie hidden within Earth's core? What wonders and dangers await us as we delve deeper into the heart of our planet? The answers to these questions may hold the key to our future among the stars.